done to see that. You can see in some of it, and this happens every year, that in some of these we're just going, yahoo! It's like they got a drunken driver over here who's winding his way through. So, okay, so we're going to compare those in terms of gaps, and you can look at the distances between your tracks, the straight line, and that's a qualitative slash semi-quantitative comparison, meaning it's more of an observational thing. But there is some description, like what's the distance between this point and this line? What should that be?
20 feet.
20 feet.
Or 12 feet, whatever.
12 feet. 3.6 some kind of meters. 12 feet. We're doing 12-foot swath, right? And so you can kind of quantitatively compare those two. Okay. Discuss the swaths and gaps, and from the observation of all the data, determine the best parallel swath. So, you know, then that's also qualitatively, semi-quantitatively. I'm measuring my swath widths and how much gaps I'm seeing in the straightness of the line. Now, like we said for the BsET students, your job is to take your track here, whichever one it is, and compare it to the track that we developed in assignment 6 to find percent cover, percent areas, what percent of my field was covered with single spray, what percent was covered with no spray, and what percent was covered with double spray. Now, I'm not telling you how to do this. There's many ways to skin that cat, and there's techniques of polylines. There's techniques of buffers on my polyline, and then there's techniques of unions, in which I'm developing unions between two polygons and finding out where they intercept, you know, where both of the polygons lie. Clipping is another technique that people use for this. But essentially, what we're trying to do is develop some maps like this. Is a little bit. I say it's hard to see, but it's the interesting part about this. So you can overlay it over the rugby field too. You can see there's the rugby field. There's actually the bleachers here. You can see that. Here's the river. So, but here's the tracks, and you can see that, oh, we've got some gaps, and we've got some overlap, and we're trying to figure out what percent of the field is single sprayed, double sprayed, or not sprayed. And these are just different techniques that do that. So, that's going to be your job to figure that out. Okay, what else do I want to say about this? This is going to be a little bit open-ended on the due date, because this is where this guidance system stuff is for test 4, and we're sort of prepping for test 3 right now. Test 3, of course, will cover the yield mapping, variable rate application, the as-applied mapping, and the control system lab that you guys are doing right now. The date for that, I don't know if I told some people, but I'm going to tell everybody right now, is scheduled for November 16th. So that's basically in about 2 weeks from yesterday. So I'm going to need to get these two labs back to you next week sometime, and we'll have the test 3 that next week.
You said yield mapping, as-applied mapping, control systems lab, and
variable rate application. Okay. GPS times there. And we'll get that. What I want to do is clean up a little bit on some of the guidance systems before we move on to other things. And I have a couple of handouts that I want to give to you to discuss. Pass that out. Passing this out. While I'm doing that, All right. First, one of the handouts is basically a description of what we went over yesterday in the lab, but I wanted you to have it so that you're aware of what the guidance system configuration and light bar configuration look like. We discussed this a little bit, but this is the handout that would cover this. Guidance, there's two configurations for any sort of parallel swathing. There's the how am I doing my guidance and how am I setting up my light bar. Swath width, we talked about that's the distance between the swaths, and that's adjustable. Sometimes you can put this in meters or English units. The basic pattern, and that was the handout where we said we can either go A to B or we can do a curved path, and we'll follow that curved path. Create the swaths. There's snap to swath, and then there's also the swath increment. And one of the problems that I think we had when we're out in the field was, what swath am I on? And if you don't line yourself up appropriately and make the turn appropriately, it can put you on the wrong swath. And I think several people ran into that, where all of a sudden they realized they were on the wrong swath, and then they had to go somewhere else to find another swath. Jessica, were you guys involved, and Tim involved in something like that?
Yeah.
So what happened in that situation?
We were on the 5th, then I turned around and headed back and was on the 7th.
On the 7th, right. And see, that's one of the problems with a setting, is that it will actually snap you to the closest swath or increment your swath. And we had this set up, so, and I'll show you the configuration, but we had it on auto turn. So when you got to the end of the field and you started to turn, it would just automatically put you on the next swath, or the closest swath. And that's one of the problems with these types of units, is this create swath, whether you snap to the closest swath or whether you increment to the next swath, and it forces you like onto swath 6. So then this has to do with headlands, what's happening at the end, the look ahead. And if the look ahead is really high, then a lot of times you do a lot of this going back and forth, because it will throw you on the other side of the line, and then you're turning back, and so you're making that adjustment. That's why I made that look ahead really short, because it basically wears the vehicle. The boom offsets, and then whether you require DCPS for guidance, or whether it basically stops operating, the system stops operating. Then the other one has to do with the light bar configuration. The LED spacing mode was linear. The LED spacing you can change. This one is set at 1 foot, and so 0 inches. So each of the LEDs that you're seeing is 1 foot. We had ours set up for a half a foot, or not half a meter. This is your approach LED. So a lot of times on the big turns, as you come back in, there's a little indicator that says, oh, I'm approaching the next swath, and to start lining up. Dash bar, light bar mount, whether it's on the roof or the dash. Display mode, and that was the correction versus the error that you would have. And then basically, there are some alarms. So if you get too far out of range, and it'll basically have an alarm that will come on. So those are the different configurations, and they all pretty much have those very similar configurations, whether it's a manual guidance or an automatic guidance system. And that's what I want to. That's what I want to refer to right now, is the different systems.